If you like factoring, you're going to love this question. Justin Z sent me this question, and it's asking us to find and classify all discontinuities of this function. F of x is equal to x cubed minus 5x squared minus 24x over x cubed plus x squared minus 72x. So we're going to look at the numerator first, which is x cubed minus 5x squared minus 24x. So the first thing you notice is all three of these terms have an x in them, so we can factor out an x. And we're left with x squared minus 5x minus 24. And remember, when you're trying to factor a quadratic, you're looking for two terms that multiply together to get negative 24 and add together to get negative 5. So I can split up the negative 5x and I get x squared minus 8x plus 3x minus 24. And now we're going to factor by grouping. The first two terms have an x in common, so you can factor that out. The second two terms have a 3 in common, so you can factor that out. And now the two remaining terms both have an x minus 8 in common, and we get x times x plus 3 times x minus 8. So that's how you factor the numerator. We can put that back in the numerator, and now we can turn our attention to the denominator. Here we have x cubed plus x squared minus 72x. And the same process is going to work. We're going to factor out the x that's common to all three of those terms, and we're left with x squared plus x minus 72. This time we need two numbers that multiply together to get negative 72, but add together to get 1. Those numbers are positive 9 and negative 8. So we get x squared plus 9x minus 8x minus 72. Again, the first two terms have an x in common. The second two terms have a negative 8 in common. And then you notice that both of the remaining terms have an x plus 9 in common. So the factorization here is going to be x times x minus 8 times x plus 9. And now we've completely factored both the numerator and the denominator of this rational function. We're trying to find the discontinuities. Well, the discontinuities are when your denominator is 0. So that's at 0, 8, and negative 9. Notice here, you're not allowed to let x equal 0 because that will put a 0 in the denominator. But there's also an x term in the numerator. So for any value that's not 0, that x over x is just going to cancel out. So this is only going to be a whole. The same thing is going to be true when x is equal to 8. And if you want to know where these wholes are, you just cancel out your x over x and your x minus 8 over x minus 8, and you can plug in your points. So at 0, we get 3 over 9, or 1/3. So even though the function is not defined at 0, there's going to be a whole at 0, 1/3, which means the function is getting very, very, very close to 1/3 when x is getting close to 0. The same logic applies when you plug in 8, except this whole is going to happen at the point 8, comma, 11 over 17. But when you let x equal negative 9, you see that the numerator is going to be non-zero there, but the denominator is going to be 0. And that's a big problem. That's going to be a vertical asymptote, which we sometimes call a pole. So we have holes at x equals 0 and 8, and a pole at x equals negative 9. Thanks for the question, Justin.